We're going to look at composition of functions, which is the most difficult construction when we have two functions and we combine them to make a new function. So we use this term to indicate the situation where we apply the functions consecutively. So given two functions f and g, the composite f, and this circle is read as after g, so this symbol means f after g, or the composition of f and g in that order. And this is given by f after g of x is f of g of x. So first we apply g to x, and then we apply f to the result. And we don't just give the formula for this function, we also specify a domain for this function. So this function will come with a specified domain. Let's start with the formula. Suppose f of x is x squared plus 1 and g of x is the square root of x. Then f after g of x is f applied to g of x, so it's f of the square root of x. So everywhere we see x in the formula for f, we put the square root of x in order to get f after g, and we get that f of the square root of x is the square root of x squared plus 1, which is x plus 1. Now, it's not the same as the function x plus 1. This function f after g comes with a description of its domain, and because of how we've constructed it, its domain is the set of all x for which we can apply first g and then f. So first of all, the x must be in the domain of g, because we must be able to calculate g of x first. So it's every x in the domain of g, and then we must be able to apply f to g of x. So it's x in the domain of g such that g of x ends up in the domain of f. Let's look at our example. We have a formula for f after g when f of x is x squared plus 1 and g of x is the square root of x. And the domains of these are pretty easy to write down. The domain of f is everything from minus infinity to infinity, and the domain of g is every x value greater than or equal to 0. Now we have f after g of x, as we saw above, has the formula x plus 1, but its domain is restricted. So the domain of f after g, according to this, it's x an element of the domain of g. So it's every x in the interval from 0 to infinity, including 0, such that when I apply g to that x value, I get something in the domain of f. Okay, so what is g of x here? This is x, every x value greater than or equal to 0, so that the square root of x is somewhere between minus infinity and infinity. Well, that isn't really a restriction. The square root of any number, any positive or any number greater than or equal to 0, is going to end up in this interval. So there's nothing limiting in this statement. So this is just all of the x values between 0 and infinity, including 0. And so the domain of that is everything from 0 to infinity. So notice that f after g of x has both a formula and a specified domain. So it's a function with a restricted domain, which is something we talked about when we introduced functions initially. Notice also that f after g is not necessarily the same function as g after f. So you might try to calculate g after f above, and then see the result when I do this here. So g after f of x, by definition, It's g of f of x. Now the rest are details, just filling in what we've got here. It's g of x squared plus 1, and g, of course, applied to that is the square root of it. So g after f of x has the formula the square root of x squared plus 1, but remember that's just half the story. We also have to figure out its domain, because this is a function with a restricted domain. Now, according to the definition, notice here I'm solving these just by looking at the definition and basically filling in the details. So I first write down the definition. That's x in the domain. Now it's in the domain of the inner function, so it's in the domain of f this time, such that when I calculate f of x, I can apply g to it. Now I fill in some details. I know what the domain of f is, so this is x in the interval from minus infinity to infinity. And when I apply f to x, what I get is x squared plus 1. So it's such that f of x, which is x squared plus 1, is in the domain of g, which is the interval from 0 to infinity, including 0. Okay, let's think about that. I'm looking for all x values, all real numbers, so that x squared plus 1 is greater than or equal to 0. So this is the set of all x in the real numbers. It's any real number because this is the entire real number line, so that x squared plus 1 is greater than or equal to 0. Okay, let's see what that turns out to be. It's all real numbers, such that x squared is greater than or equal to minus 1. Now, that's every real number, because any real number, its square, is going to be greater than or equal to 0, so therefore its square is going to be greater than or equal to minus 1, so that's just all real numbers. But that's just the entire interval from minus infinity to infinity. And notice, of course, that f after g is not the same as g after f here. They have two entirely different formulas and two entirely different domains. Let's try to calculate f after g at a particular point. Now, of course, you should try this question yourself and then have a look at the answer later. I'm going to calculate both the formula for this and its domain. So first of all, let me write down the domain of f, and that's the set of all x with two restrictions. One, we have to have 1 over x minus 3 greater than or equal to 0. So we must have x is greater than or equal to 3. And we must also have that x minus 3, the denominator here, is not 0. So we must also have that x is not equal to 3. And of course that means the interval from 3 to infinity without the 3. And the domain of g here is, as before, it's the set of all x greater than or equal to 0. Let's find a formula for f after g. That's f of g of x. So it's f applied to the square root of x. So everywhere I see an x in the formula for f, I'm going to replace it by the square root of x. I end up with the square root of 1 over the square root of x minus 3. What about its domain? That's its formula, the domain of f after g. Well, according to the definition there, it's equal to the set of all x to which g can be applied, so it's x in the domain of g, such that f can be applied to g of x, so such that g of x is in the domain of f. So that's the set of all x in the interval from 0 to infinity, such that g of x, which is the square root of x, is in this interval the domain of f from 3 to infinity, not including 3. Okay, so it's all numbers greater than or equal to 0, so that their square root is greater than 3. And so we see that that means that the x values have to be bigger than 9. So it's the set of all x greater than or equal to 0, such that the square root of x is bigger than 3. We have two conditions, and of course this is the defining one, and so that's the set of all x greater than or equal to 0, such that x is bigger than 9, that's squaring both sides there, and anything which is bigger than 9 is automatically bigger than or equal to 0. It satisfies both conditions, so this is the set of all x bigger than 9. It's everything from 9 to infinity. So here we have the formula for f after g, and we also have its domain is everything from 9 to infinity, not including 9. How about f after g of 16? Well, certainly 16 is in the domain, so we don't have to worry about that. And f after g of 16, well, I can just apply the formula. It's the square root of 1 over the square root of 16 minus 3, and that's equal to the square root of 1 over 4 minus 3. That's the square root of 1, which is 1. So my answer there is 1, and I'm done.